Welcome and hello. This is a video tutorial on HEC DSSVue, and in this lesson, I'm going to talk about scripting. Okay, this is another example about scripting using hydrology and DSSVue. All right, what we have in the interface here is our DSS file is loaded, and we have a couple data sets. This second one here is the one we're going to be working with. It's a hydrograph you can see over the course of about 5 days with flow rates that peak at about 40,000 CFS. What I want to do in this example using a scripting is to determine the volume of water. So it's the area under the curve here. And I want to determine the total volume as well as the storm contribution of that volume because the base flow would be the difference between the total and then the storm contribution. All right, so let's go ahead and get into it. Let's peek at the numbers real quick. These are the values. So this hydrograph starts on early morning, October 24th, and then with some of the first values around 1300 CFS. And then it peaks about around 40,000 CFS. That's October 25th in the late afternoon, early evening. And then at the bottom, it ends at late night, October 28th at time step 115. So it's not quite 5 days, but it's close. And it is an hourly time step. All right, so let's go over to Tools and then Script Editor. And then we can go File New or File Import. I'm actually going to import this one. I've been working on this script over in Notepad++, and it's on my desktop. So it's this file here, Get Hydrograph Volume. Let me go ahead and show you this file first and what we have before importing it and running it. So here's the file. And at the top, I've got some normal imports that were all required. And then the next section here is getting the data. And then below that, it's calculating the volume. And then the last part here is printing the results. So let's talk about this script a little bit. The first part is getting the data. And we've seen a couple of these steps in previous lessons. The line 10 here is opening the file, which is just a path to the DSS file. I want to get all the data, so no second parameter. Next, I'm just defining the dataset path. We can find the file name and the path over in DSSVue. Here's the file name, and then the path would be if I right click, rename. Here is the path name. So that's all hard coded. Next up, line 12. This is critical. This is actually grabbing all the data from that data set based on the file and the path name. Okay, after that, with the data set, I've double clicked it. It highlights where I'm using that. The next 4 lines, I'm getting the values, which represent the flow rate in CFS, the time, which represents the minutes, and that's a large number that is referenced from some data point in the far past. I'm using times for the difference in times so that I care more about the time difference, not the actual value itself. Next up is interval. That's going to be 60 minutes because this is a 1 hour time step. And then the record count is the number of records. And we know that's 115 by looking at the table. But I wrote the script so I don't have to look at the table. And like the times are calculated with using a DT. So even if we're missing a record, it would calculate it 2 hours or 3 hours or whatever instead of just one. And then, yeah, this record count, the 115, I'm using that to loop through 115 records from 0 to 114 as my index. Okay, so that's getting the data. The next step is to get the base flow. For this problem, I just assumed that the base flow was the minimum flow rate of all the values in the time series. That may not be accurate, but it's good enough. This is just a Python code to get the minimum value. I could have wrote my own for loop to determine that, but this is fine. Next up, I initialize the total volume. So the total volume is 0, and then the storm contribution total volume is also 0. That's the total minus the base flow. All right, the next step is to actually calculate those volumes. So what I did here is I looped through each time step, and then I set the flow rate for that time step and the time. Uh, and then let me skip ahead. At the very end of the loop, I also update the previous time and previous flow rate. So what you're seeing in this middle section here, I skip for the very first record where I equals 0. And what I'm doing is, even though there's 115 time steps, I'm only going to calculate volume for 114 durations. Because what I'm doing is I'm finding the average flow rate for that hour based on the two consecutive flow rates, and then multiplying by that duration, the dt. So yeah, line 31, I get the dt. It's in minutes, so I multiply by 60 to get seconds. And then 32 and 33, I'm getting the average flow rate. So this is for the total. It's just the flow rate plus the previous flow rate divided by 2. And the storm flow rate is that minus the base flow. Okay, the next step is to calculate the volume. Like I mentioned, that's multiplying the dt times the flow rate, and then converting it to acre feet. And that's for the total hydrograph as well as the hydrograph for just the storm contribution. And then these last two lines is where I increment the total volumes that were initialized to 0 for each time step. All right, so that's what's happening here. And at the very bottom, I just format the output to be 2 decimal places and add a comma at the 1,000 mark for formatting. And then this last line of code just prints it out to a message box. Okay, enough talk. Let's go ahead and see what that looks like in practice. I'm going to go Tools, Scripting Editor, and then File, Import, and then let's go to the Get Hydrograph volume.py. Here is the script loaded up into the scripting editor. The label is auto-populated. That's fine. I'm going to go ahead and click OK, and then click the button to run the script. And sure enough, we have results. It says the total volume is 97,905 acre feet. And then the volume from the storm is 85,161 acre feet. So the difference would be the base flow, which is approximately 12 or 13,000 acre feet for that almost 5-day duration. So this is just another example of how you can use scripting in DSSVue to solve some hydrologic problems.